Hey guys, welcome to 3.3, Nearest Neighbor Notes and Practice. Now, Nearest Neighbor is going to introduce us to what are called approximate tours. And the reason why we have these is because brute force takes too long. If n is greater than 4, it's going to take you forever. So we need a faster way to come up with a good answer. And that's what Nearest Neighbor helps us do. So to start, you go to your designated vertex. If there is no designated starting vertex, then pick any vertex. I would suggest starting alphabetically, go to A, go from there. Now, from that starting vertex, you're going to go to the nearest neighbor. Which is the smallest number here? Well, it's 119. So I'm going from A to C. All right, smallest weight leads you to the nearest neighbor. Next, we're going to go to the next nearest neighbor. So from C, I'm going to look and say, all right, I've got 120, 174, and 121. I'm definitely traveling 120. All right, now I'm going to keep going until I reach every vertex that hasn't been visited yet. So I can't use 133 because that would be taking me to A, which has already been visited. So that leaves me a choice between D at 199 and B at 200, and for a difference of $1, I'm going to D. From there, the 152B is my nearest neighbor. And then from there, I go back to A. So you can see here, we're following that circuit. We're left with A to C, which is 119, C to E, which is 120, E to D, which is 199, D to B, which is 150, and B to A, which is 185. Add those up, and we get a weight of 773. But wait a minute. Brute force told us that 676 was the optimal tour. Well, yeah, our answer isn't optimal, but the process was quick. So Willy Loman, our traveling salesman, has to decide if the time he saved by not doing the brute force algorithm is worth the money he's going to lose from the difference. We say that the nearest neighbor method is approximate and efficient, as opposed to brute force, which is optimal and inefficient. All right, so let's take a look at what happens if the territory gets expanded to 7 cities. Well, this is a lot. And I'm going to tell you guys right now that doing things like this, problems like this, by hand is difficult. It's easy to get lost. I'm telling you that because hopefully you will have a version of this that is fixed. However, if you have a paper copy, it might not be. It's easy to do things wrong. And I am the author of these notes. And when I created them, I did something wrong. I looked at a column, I saw something, and I wrote something else. So let's talk about it. Let's talk about how to do this correctly and how mistakes can be made so that we can avoid them in the future. So a territory gets expanded to 10 cities. I'm going to start at A. So we look down column A, and I see 119 right off the bat. 119 is pretty low. In fact, it is the lowest connector. So C is A's nearest neighbor. So the nearest unused neighbor is C. Now we're going to look down column C. All right, I see 120. 120 is the lowest, but 120 is not D. 120 is E. And here's the fun part about doing any sort of sequential work, if you get one part wrong, rest kind of just fall like dominoes. So let's work our way through this together to see what the actual right answer is. Now, I'm going to cross out in that 119 here because that was already used. Now I'm going to go to column E. I'm going to look down column E, but I'm going to cross out A because I cannot connect to A yet because I'm not done. And I'm going to cross out C because that's where I came from. Looking down, I've got 200, I've got 199. 199 it is. That is my nearest neighbor left from E, and that is D. So from E, I am going to be traveling down to D. So now I'm going to reference column D. I cannot go back to A. I cannot go to C because that's already been used. And E is where I came from. So what is my unused nearest neighbor? Looks like it's B for 150. All right, so from D, I'm going to B. All right, let's pop over to B and let's see what we see. I cannot go to A because I'm not done. C is already used, D is already used, E is already used. So let's see what's left for me. F is 404. Oh, J is 379 and is the nearest unused neighbor. So that is going to be J. Let's connect B to J. All right, popping over here to J. I cannot use A, B, C, D, or E, because if I look, those all already have two lines coming out of them. If I add a third, that means I'm visiting it more than once. Okay, so I have F, ooh, G looks good, and G stays looking good. 241. And that was from J to G. 241 to get from J to G. All righty. From G now, I cannot use A, B, C, D, or E. I also cannot use J. That is C then. That leaves me with F, H, and K. And I'm going for K. 235. Hey, that happens to be right, and I don't have to cross it out. All right, so we are going from G to K. Now let's look down column K. All right, I cannot use A, B, C, D, or E. I cannot use G or J. So out of the two left over, F and H, I'm going F, not H. I'm going F for 222. All righty. So from K, from F, I cannot use, oh, let me just mark that we're going from F. I cannot use A, B, C, D, E, G, J, or K, which leaves me with one option, and that is to go to H. All right. Oh, we didn't mark here, or I didn't mark here that from K went to F, and from F then down to H. So H then must return back to A. All right, cool. So that is going to alter what we have down here. Let's look. Instead of that being our approximate tour and our weight, let's see. Our tour now is A, C, E, D, B, J, G, K, F, H, and then back to A. And let's double check. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices, and then back to where we started. To find the weight now, all right, A to C is 119. C to E is 120. E to D is 199. D to B is 150. E to J is 379. J to G is 241. G to K is 235. K to F is 222. F to G no. A to C, C to E, E to D, D to B, B to J, J to G, G to K, K to F, F to H. There we go. Woo! 211. Plus, finally, we're going from H to A for 277. All right, let's add that up and be done with this. 119 plus 120 plus 199 plus 150 plus 379 plus 241 plus 235 plus 222 plus 211 plus 277 is 2153. All right, but what if I wanted that circuit to start at B? Well, we would not do that because that's for the bad one. We would just rearrange the points. So I have to travel from B to either D or J. I'm going to go to J. Then I have to go to G, and then K, and then F, and then H, and then A, and then C, and then E, and then D, and finally back to B. And that's just writing it from a different reference point. Okay, let's do some practice. Here we have the price of a bus ticket between cities V, W, X, Y, and Z. We're going to start and end at Z. Find a Hamilton circuit and its weight using the nearest neighbor algorithm. Okay. From Z, my nearest neighbor is V. I'm now going to go to V. I cannot use Z. That's okay. My nearest neighbor is X. All right. From there, I'm going to go over here to the X column. I cannot use Z. And I came from V, so I have to choose between W and Y. Y is my nearer neighbor. Going over to Y, I cannot use V. I cannot use X. And I can't go back to Z yet. So I have to go to W. All right, from W, I cannot go to V or X or Y. Nope, it's my last one, so I am in fact going to be traveling back to Z. So my circuit is Z, V, X, Y, W, Z. And my weight there is going to be 45 plus 10 plus 30 plus 37 plus 60. 45 plus 10 plus 30 plus 37 plus 60. All right, so I have a weight of 182. Let's try the next one. We're going to use the nearest neighbor algorithm to find a Hamilton circuit starting at A. Same thing here, where we're going to write down the circuit and its weight, but then this time we're rewriting the same circuit originating at E, or choosing a different reference point. All right, from A, 9, 8, 7, 13, 16. So 7 takes me to D, which is my nearest neighbor. From D, 15, 10, 11, 12. So 10 takes me to F, which is my nearest neighbor. From F, I cannot go back to A. That doesn't matter, I don't think, because we have 6, 3, and 2. I'm going down this way to E. From E, I cannot go back to A. I must go to either B or C. B is 14, C is 11, so I am going to C. 12, 3, but I can't go there. 13, 4. There I go. And as I have now visited every vertex, I'm going back to A. All right. So my circuit then is A, B, F, E, C, D, A. Now let's find the weight. A to D is 7 plus D to F is 10 plus F to E is 2. E to C is 5. C to B is 4. And B to A is 16. Now, I know earlier I said 11, but that's because I was looking at this one and not this one. So E to C is 5. All right, let's see what that equals. 7 plus 10 plus 2 plus 5 plus 4 plus 16 is 44. Now let's rewrite it from E. E's my new reference point. From there, I'll move forward to C, and then B, and then A, and then D, and then F, and then E, because I'm just rewriting this from this point instead of this one. All right. For your final one, you're supposed to pick 5 cities in the US that you would like to visit. Find the distance between them in miles using Google. If you don't have access to Google, you can make your best guess. You're going to create a K5 complete graph with the cities as your vertices, and you're going to label your edges with your mileage. Use the nearest neighbor algorithm to find a Hamilton circuit and its weight starting at the city of your choice. I'm going to leave that one up to you. There's a lot of different cool things you can do with this. If any of you want to pick strange and interesting cities in the US that I may not have heard of, that'd be awesome. Surprise me. All right, guys, good job. I'll see you next time for 3.4. Have a good one.